Alright guys, so today we're going to be looking at projectile motion, and we're going to be talking about the different parts of projectile motion and how it all works to apply to different contexts, in particular in sports. Now, the example we've got over here and a bit of a description is that projectile motion is about the form of motion of which an object, for example a ball, a car, a bike, snowboarder, a person, something that like that they take once they're thrown, they've jumped off of a ramp, been kicked or driven. So it's pretty much anything that's traveling in the air has got to do with projectile motion. Now if we have a look at this image over here, we've got a motorbiker, and he has just jumped off of a ramp just over here, and he is in midair. And there's two parts of projectile motion that we need to know about. First of all, we need to know what the projectile is. So for this example, our projectile is our motorcyclist, okay, and obviously there he is over there. So here's our projectile. Obviously if that's a rugby ball and it's being kicked, that is our projectile. Then same thing if it's a tennis ball or a cricket ball or a baseball or a shot put or a discus, that's the projectile. It's the one that's actually traveling in the air. So just to make that nice and clear, so we've got our projectile over here, which is our cyclist. Now the last part we've got is our parabola, okay, and this is pretty much the path that the object or the ball or the person takes. So in this example over here, if you look in green, I'm going to draw now, the parabola is the path it takes. So this is the parabola of the motorcyclist, and it's important to know, obviously the parabola is always in an arc and it's traveling up, and obviously there's an impact on that parabola, okay, or on that person or object, and that's gravity pulling down. Going through the three main parts to projectile motion, the first is angle of release. So you can see over here we've got an example of Angry Birds, alright, and the person's pulled down the little slingshot. Now angle of release obviously is very important. Your angle of release is going to change depending on where you're shooting the bird in this case over here, or where you're throwing a ball or kicking something. Obviously if you want to chip something over a tree, okay, you're going to need obviously a steeper angle of release to get over there, whereas if you want to shoot something underneath, or you want to possibly get an object further without traveling too far in the air, your angle of release will be less. For this example and for shot put, the optimum angle of release angle is 45 degrees. Now if you have a look over here, it works out a whole range of different types. Obviously we've got 45, 60, 70 degrees, so we've got a whole range of different types, and you can see there for 20 degrees obviously it travels more horizontally than vertically, okay, therefore obviously if gravity is impacting on that, this is not going to travel as far. The reason why is that the vertical part. So if we have a look at the different angles over here, and in particular the 45 degree angle, okay, it's got a great vertical and horizontal aspect to it, and it allows it to travel further. So if we're applying it to any throwing events, 45 degrees is our optimum angle of release. That will obviously change depending on the context and what you're trying to do. The second part is speed of release. Now this also impacts a little bit on projectile motion in terms of how fast the object is actually released. So just looking at this example over here, obviously the speed of release was going to impact on the distance traveled for the bird in this particular example. Okay, if it's a lower speed of release, even if you have a 45 degree angle, that distance is going to change depending on the speed of release. The last part is height of release, and all this is looking at is what height is it released from. If you have a look at the example just down below over here, we've got somebody who's throwing two separate balls, and we've got the parabola for each of them. Now if we have a look at the third example over here right now, the person is throwing it from a height. If we had to compare the three to each other, we would say that the very first one over here would gain more distance. If they both had a 45 degree release angle with the same power or same speed of release, then this one over here would have the furthest throw. And the reason why is when these ones release the ball, they're closer to the ground, so therefore there is less chance and less time for the ball to travel in the air. Whereas if we're throwing it from a height over here, the same angle, okay, we're going to have more time for the ball to travel in the air and more time for gravity to impact on it. Therefore, it'll gain a longer distance. Now, obviously, if we're thinking about height of release and shot put or discus, unless you're throwing from the top of a mountaintop, there isn't going to be a huge impact on that. However, if you went to the top of a mountain and you threw a discus and you compare it to throwing off the ground, there would be a change. So in summary, obviously 3 parts to projectile motion. Okay, there is obviously the angle of release, speed of release, and height of release. Okay, all 3 of these components work together to give us projectile motion. Okay, the arc that you can see in the very first example over here is the parabola, and obviously the ball, object or person is the projectile. Our optimum angle of release is 45 degrees. Speed of release does impact on our projectile motion in terms of a higher speed of release obviously will result in a further distance. Height of release, once again, if you're throwing objects from a higher position, then the distance traveled is going to be further in comparison to one off the floor. So exit task or extension task for you is to have a look at a sporting activity, and I want you to apply projectile motion to a chosen activity. And this can be written or verbally with a partner.